Okay, section 1.5, investing involving regular payments. Now, up to this point, we've talked about simple interest, where we have a formula for that. We've talked about compound interest. We have several formulas surrounding the compound interest, right? We've manipulated the one big formula. We can calculate future value with compound interest. We can calculate present value. We can calculate interest rate and so on. And even n, we can find n. So in 1.5, it's a bit of a different situation. This is investments involving regular payments. So what that means is you put some money in the bank and it starts accumulating interest. And then at a regular interval, you put more in, and then more and more. So you have stages where you don't put a big lump sum in and just leave it alone for 100 years. You put in a little bit of money here, and then a little bit of money next paycheck, and so on, which is the case with example 1. Now this gets a little bit complicated, so I'm going to show you how to use the graphing calculator. The TI-83 has a finance program, and to tell you the truth, if you have an older calculator, you might not have this program on, but like most of them do. So if you want to check that right away, you can check it. Let me just see here. The calculator looks like this. If you have an apps button, if you do not have an apps button, that means you have an older one, and you can try and get one with an apps button, but to be honest with you, if you want to just move over and look at somebody else's, that's fine too. In the apps, you should have a finance. So if you go to apps, you should have a finance. Some of you may have lots of applications, but choose the finance one. Okay? But we'll come back to that. So here's the example. It says, the example says, Darva is saving for a trip to Australia in 5 years. She plans to work on a student visa while she's there, so she needs only enough money for a return flight and her expenses until she finds a job, blah, blah, blah. She deposits $500 into her savings account at the end of each 6-month period from what she earns as a server. There she is right there, Darva. The account earns 3.8% compounded semi-annually. How much money will be in the account at the end of 5 years? So with regular payments, you're going to have to do a series of different calculations and add them all up. That's if you're doing it sort of the long way. I want to show you how to use your calculator. So if we go back to the notes here, where are they? Over here. Yeah, that's you guys. If we go back to the notes here, right here, what I want you to do is I want you to get on your calculator and hit that finance app. So it's right here, finance, hit enter. And in the finance, I want you to select TVM Solver. I don't know what Solver means. TVM. Okay? Now, you see on this screen, if you have this screen, if you don't, you can just watch up here for now. But if you have this screen, you have N. You see N? That's the N in our compound interest formula, which is what? A equals P1 plus I to the power of N. There's N. Now, they use a capital N. No big deal. Doesn't matter. They use a capital I as well. Okay? That's because this is the yearly percent always. You don't have to do any calculations. It's not small I. It's annual interest. The calculator does all of that rest of it for you. Now, PV means present value. Okay? PMT, what do you think that means? Payment. Okay? And if you are giving it away, it's a negative. Okay? Not a real big deal, but if you see a negative on one of these values, it does mean something. So if you are paying it out, if it's leaving your bank account, then it's a negative. It's going away. And then FV is future value. Okay, and this is what we're going to solve. Okay, I took this clip of the screen because this is what we're going to solve for. And you don't put a number like this in. This is what you actually get at the end. Now, just real quickly here, P/Y, that's payments per year. So in this question, and this is the screen for this example, that she's putting in every 6 months. So that's 2 times per year. And the compounding period, okay, or the compounding periods per year, if we just go back there, where was that? Oh, yeah, up here. Compounded semi-annually, okay? So C/Y, that's compounding times per year, is 2 as well, okay? So on your calculator, all right, so the N, while we do need to know the N, it's, what is it? The number of compounding periods is 5 years times 2, right? So, this is not for this question. So 5 years times 2 is 10 compounding periods, I guess. The interest rate, so plug these into your calculator as well, see if you can do it as well on yours, is 3.8. Present value is 0. Now, why is it 0? Because she puts in $500 at the end of every 6-month period. So at the very beginning, there's nothing. The payment is at the end of this payment per year, so it's at the end of the 6 months. The payment is, we said, negative 500. The future value, I guess that's what we're looking for. So you can kind of, I don't think you can leave it clear, actually. So just leave it as whatever, 0. Payments per year is 2, and compounding period per year is 2. So let's see, is that what we have? Is that what we have from my clipped screen? Is that the same? Okay. So then on your calculator, what you do is you go up to, future value right here. And then, this is important, you see down here in enter, you see this in kind of turquoise, it says solve. That's when you hit the alpha button, and then enter. And you solve, and that's how much money that she will have in this situation, $5,449 right here. Okay. Yeah, you leave the 0 there, and then you go up with your cursor there, and then you click solve, and it'll solve for future value. So you can solve for the interest rate too, like we just did. If you clear that out and you say alpha, enter, it'll calculate the interest rate. So yeah, you can, this is the easiest way to go with payments, okay? So we should do one more example. Example 5 says on Lewis's 20th birthday, he started making regular $1,000 payments into an investing account at the end of every 6 months. He wants to save for a down payment on a home. His investment earns this much compounded semi-annually. At what age will he have more than $18,000? Okay, so future value 18, and we want to know how long, right? So what is that on our calculator? That is n. Okay, we're going to be able to figure out how long from n. So n looks like what we're trying to solve. So the interest rate, let's do this quick. 3.5. Okay, compounded semi-annually, so that is compounds per year 2. What else do we know? He makes at the end of every 6 months, so that's good. End of every 2 times per year. See that? Right there. And he makes regular $1,000 payments. Okay, so let's go down to here, and he's giving away $1,000, or negative 1,000. Okay, so it looks like we're trying to find n. Future value. We didn't do that one. Future value, it needs to be what? At least $18,000, right? Okay, so does that look good? We got everything in there? PV is present value. Okay, so let's see if, let's do calculate here, and, okay, 15.78. Let's see if that matches up with what the book is saying. Look at that, 15.784. Number of payments. Okay, so we did that pretty quick, pretty easy. So that's, remember, 2 times per year. So if we round up to 16 payments, that's going to be a little bit more than 18,000. So 16 payments represents 8 years, because it's 2 payments per year. Okay, so that's how you use your graphing calculator, the TVM Solver. Yeah, I'm going to give you an assignment. You can work on that here real quick. Yeah, I don't know. It does go into Mac. You just have to find the right site. It doesn't have to be an 83. It can be any graphing program. It's easiest if it's this calculator because we're working with it, but it doesn't have to be. So I don't know. It's just something you'll have to work with, I guess. Okay.